Ladies and gentlemen, hello and welcome back once again to the briefing room. My name is Eric Cavanaugh. I will be your host for today's event in which we're going to tackle one of the hottest topics out there in the world of information management. I can tell you that. So let's just dive right in here. My name is, of course, Eric. You can see a slide about yours truly right there. And let's see, the mission of the briefing room is to reveal the essential characteristics of enterprise software, good and bad, provide a forum for detailed analysis, as you can see. And many of you know this format before. So the topic of the month is analytics. We'll be digging in on several occasions. We're going to talk about big data preparation. So we're going to talk about how you can get there, what you can do to make sure you figure out how to get this stuff. So let's see, Analyst Robin Bloor. Now I'm going to go ahead and hand over to our folks from Pervasive. And let's see, Joe, I think I'm going to hand it to Jim. So let me hand it to you. Yes, I do.
Oh, I'm sorry, Eric. We're going to start with Joe because we're going to be doing the presentation first. I'll be doing the demo.
Okay, good. Go ahead. So, Joe, you want me to give you the slides? Hold on.
Okay, just made Joe the presenter.
Okay, go ahead. The floor is yours.
Okay. Good afternoon. Thanks, Eric. This is David Inbar from Pervasive's Big Data Products Group. I'm going to be spending a few minutes this afternoon outlining our view of the big data scene, big data challenge as we know it. And the first legitimate question to ask before we dive any deeper is, yes, there's a lot of big data, but where are the wildfires, or what's causing a lot of the challenges? And of course, the classic ones that I think everybody knows about, which is all the traffic that people talk about in social media, including Facebook, including Twitter, a lot of blogging. There are specific industry verticals, bioinformatics being one of them, where the technology is starting to produce enormous volumes of data at ever-increasing rates. And then there's the traditional transactional arena. What's interesting, though, is aside from telecoms, which I think everybody understands has been a big data arena for a long time, you start looking at utilities and smart meterings and smart grids, which have been talked about for quite a while. But you can see on here a logo for Austin Energy. Happens to be where we're headquartered. Not a particularly big community, reasonably sized, but not huge, but starting to produce literally an avalanche of data, actually, which as more and more smart meters get installed, and then you start monitoring them instead of once every week, we go to every day, and then we go to every hour, and potentially more than that, the data volumes start to climb very, very quickly. And so there's a mix here of what I'd call unstructured data, or even media with photos and so on. And then there's more transactional type or machine types of data. And that's really the big data fire hose that's not even filled up yet, but beginning to appear, I think, for everybody. And you can see here an interesting projection from the McKinsey report. And when I first looked at it, I was pretty surprised, not necessarily just at the overall scale with which the Internet of Things or machine-generated data starting to appear, but the areas that are growing here. Because I would have thought there'd be a lot more growth in the retail area. There is, but the absolute growth, when you see things like utilities, automotive, that means all the data that's being generated now in every single car that we drive. And every time you drive into the service shop, these days mechanics a mechanic has to plug in to a computer so they can download data and they can monitor what's going on. And those volumes are climbing very, very rapidly, as are other areas of travel. Every time you take a flight across the Atlantic, you and your fellow passengers are responsible for generating, another 3 terabytes of data. Interestingly enough, by and large, when the plane lands, that data is discarded because there really isn't enough capacity right now, not so much to store it, but then to actually analyze it. And if you accumulate that data for hundreds of flights a day or thousands of flights a day, every day of the month, every month of the year, you could have some very interesting intelligence in there, but getting at that data and getting at the intelligence and the analytics is a challenge. So if we go to the next slide, and we reference classic big data, what we call hotspots or pinch points in the flow of data. In many ways, if you're in the analytics business or the data prep business, if you're in IT moving data around, you probably experience pinch points anyway in either your collection processes or your prep processes or your analytics processes. With the avalanche of big data that we're just starting to see now, those pinch points are absolutely critical, and we're seeing those as one of the key obstacles to actually getting useful value out of all of this data. And you'll see a lot more about this particular combination or sequence of collect, prep, analyze, and consume in subsequent slides and in our demo. But what's also interesting about this is, below the volume and velocity line that is increasingly a challenge for organizations. I've sketched out a few of the roles that are classically involved in capturing data, working with it, analyzing it, and making it fit for consumption downstream, either by humans or ultimately in closed-loop systems by machines. And what we're seeing a lot in the big data space is that there's a lot of complexity in adopting new platforms like Hadoop, or in just handling large amounts of data. And there's a real skills gap. So there are technology gaps, there are budgeting and cost gaps, and there are skills gaps. And the next slide, if we go to it, is an overview or summary of the gap that we see, that there's this enormous potential, we believe, from the huge volumes of data that you can actually wring value, wring insight, wring improved processes out of it. But the amount of value that's really being delivered from that today, particularly as those volumes grow, is still relatively small. We're seeing maybe, it's a somewhat arbitrary number, but it's probably in a single-digit percentile of the value that could be extracted from all these different sources of data if the right skill sets were available, the right tools were available, the systems were easier to use, architecture in one form or another was less of a constraint. And we're seeing it big time with our partners and our customers. So if we go to the next slide, Joe, thank you. So this is, if you like, a related diagram of what should the software, if you like, fire hose look like that's going to drench all these fires in cooling analytic capability. And we've listed it out here. There's clearly a need for end-to-end functionality because, if big data hits a bottleneck either at the collection stage or at the preparation stage or at the analytics stage or even at the consumption stage, your other investments are going to have been wasted, and you need really very, very high performance, high bandwidth flow end-to-end with all your processes. Ideally, whatever you're using should be rapidly adoptable, learnable, usable, by business users and analysts and not require coding or programming. It needs to be high performance, and we've talked. You hear a lot about scalability in the arena of Hadoop. With that, very often though, comes performance that's not optimal. So high performance on whatever hardware platform or architecture you're running on is critical. Being able to take your analytics or your data prep flows and ideally develop them on regular architectures and deploy them on distributed Hadoop, or develop them on Hadoop and then downsize them onto regular servers would be an ideal. And whatever you're doing, if you have tools that have predefined functions that speed the work along, can they be extended and can you get reusability? So I think that sets the scene, and I've gone pretty fast here, for taking a look at how we're approaching this with a product of ours that we launched recently called RushAnalyzer that tries to address this end-to-end need. So Joe, if you could switch over to Jim and we'll take a quick look at the software and some use cases, I think that might be helpful.
Okay, there you go.
Okay, thanks, David. So what we're seeing here is this RushAnalyzer environment, which is built on the open source tool called KNIME. And this particular workflow that we're looking at, well, actually, let me back up a little bit. Let me kind of give you an overview of the tool itself. So over here on the left-hand side, we have these workflow projects. It's just kind of a way of organizing your work. And what each one of these projects represents kind of a flow here that you see on the canvas. In the node repository, we have all these different functionality that we can use, different nodes that have been added to the environment. And you can see all the Data Rush ones. Data Rush is the underlying technology beneath RushAnalyzer. So we have different I/O modules or operators, analytics, like Dave was talking about, the ability to run data mining and statistical types of operators. Association rules, we're doing it like association rule mining. If you have market baskets, you want to do market basket analysis. FP growth is one of the algorithms that we use there. Different predictive classifiers, such as decision tree, k-nearest neighbor, naive Bayes, SVM. And when the underlying technology that we're using scales up, of course, on single machines, like David was talking about. Actually, some of the workflows I'll be running today are running on my desktop. It's just a 4-core machine, but I get decent performance out of it. We also run on a Hadoop cluster, and we'll show a couple of examples of that. So again, that scalability, from the desktop all the way up to large servers to clusters using this GUI environment, drag and drop, build your workflows. Very intuitive to use. You don't have to be a all-star programmer. You don't have to know even about distributed programming. You just have to be able to link these things together, drop them on the canvas, set up a few properties, and away you go. Let's see what other things we have. Clustering, so we have like k-means, linear regression, different types of transformations. So as your data gets into your Hadoop cluster, what are the different types of things that you need to do on it to kind of prep it? Aggregations are very common, of course, different types of joins. A lot of times you need to enrich that data with maybe other enterprise level data, and we'll actually look at a workflow where we do that. Different types of filters and manipulations or transformations you want to do. Data Explorer, just for doing kind of a quick look at your data, get a summary of it, get a feel for what your data looks like. Does it have a lot of missing values, or just kind of gives you a feel for the types of transformations you may have to do to actually kind of clean the data up. And then Data Matcher, and this is based on fuzzy matching algorithm, so it allows you to bring disparate data sets together, or maybe even deduplicate it within one data set where you want to actually, a lot of times this is used for like name data, addresses, things like that, where they've come from different sources and maybe have different formats and different spellings and things like that. And you need to be able to bring that data together and run these fuzzy matching types of algorithms on it. Okay, and of course, being a GUI tool, it has nice online help, so I can just actually click on any of these and get a nice overview of the actual operator, and it kind of walks me through how to use it. This particular workflow, what we're using the TBCH data, which is kind of standard data, standard benchmark data. It's retail data, so it has customers, it has orders, line items, or transactions, regions and countries, so there's some geographic type data. And what we're doing here is actually reading the transactions, and because there are transactions, we'll have a lot of them, so we actually put those on a cluster we have here. It's just a 2-node cluster, and we're going to read the line items from there. And you can see it has things like part key, order key, line number, quantity, extended price, all that information you'd expect in a kind of a retail line item type of data set. The orders themselves are just on my local disk, the transactions coming from HDFS, and the customer data coming from a local MySQL instance that we have running in our lab. Now, it's also with the regions in the country. That information is also coming from a database. And this is a pretty common scenario that we see where, the big data goes onto Hadoop, the smaller data sets, kind of more static type data, you're just going to have those. You may have them in Hadoop, you may have them in a local database. With a tool like RushAnalyzer, you can kind of pull all that data together into one workflow, and we'll just go ahead and kick that off, and you'll kind of see how this works. Now, we're pulling data again from these transactions as they're coming from HDFS, from the Hadoop cluster. We're actually doing a little bit of cleansing on them, doing some missing values, cleaning the data up a little bit, and then joining it with a couple of our other data sources, such as the orders, such as the customers, and then again with the geographic information. And we're doing that because we want to enrich our data. We want to take that line item type data, enrich it with some of our enterprise data, and then we're going to do some aggregations by different by different dimensions of the data, such as market segments, grouping by country, grouping by region, and then we'll actually generate a report from that. And we can, as this runs, when it's done, we can then go through the report and take a look at that and get get some information from that. On the end, we could also dump this into a database if we want, kind of a star schema, multi-dimensional type of data warehousing schema. We would take those dimension data and dump it into a database for us to use. So you can see we're marching through that data. I think it processes about 6 million rows of line item data here, and okay, so it looks like we're done. We did that in just over a minute in time. So let's save that real quick, and we can actually then look at the reports that are output. And this is using a kind of a plugin into this environment that's based on BERT, which is the tool for doing business intelligence and reporting tool. It's part of kind of a tool set that's available from Actuate. And we're just using the kind of open source part of that. So let me open up the report. And just takes a minute to render this. And once it's rendered, we can actually, we can, of course, view it here. We can save it as PDF. We can actually export it into HTML and put it out on our website, and others would be able to interact with that report. And let's see, I'll just make this full screen. Here we go. And we just looked at units by market segment. Again, kind of that segmentation that we did, all the grouping aggregations that we did along some of these different dimensions of the data, by dollars by market segment, and then total revenue by region, total units by region, and then also just a kind of a table by country. So I just wanted to give you an example of the types of reporting you can do within this tool. And again, that was kind of bringing data from all these disparate sources, bringing data from Hadoop, and then being able to do reporting on it. And let me show you an example of a regression. We're going to do a linear regression over this data. It's airline data. It's actually public data. It's 22 years of domestic arrivals and departures within the U.S. and has things like departure time, what time it was supposed to arrive, what time it actually arrived, how late it was, what flight it was, things like that. And so we're just going to do a simple linear regression on the data. But again, that data is in HDFS. And actually, when we're running this one, we're going to be running distributed. And so what's happening, if we go and look at our cluster, we're actually running on the cluster. And so what's happening is we're running multiple copies of this workflow. It gets replicated. Pieces of it are distributed. Some parts have to kind of come back together at the end, and then we'll generate a PMML model. But running distributed allows us, of course, to use our distributed algorithms. All the algorithms within RushAnalyzer are distributed. All of the operators are. And so we're actually able to run within the Hadoop cluster and source the data from HDFS. We're doing locality optimizations, much like MapReduce would do, where we try to run the calculations as close to the data as possible. Of course, that's the most efficient way to do it. PMML is actually a standard. It's called Predictive Modeling Markup Language. It's an XML-based standard, and so this allows us to interact with other software that may actually, be able to apply the model. Of course, we have operators that apply the model, but you may have other ways that you want to do that. So it's a standard. Of course, we try to be standard. We're going to run over about 123 million rows of data to generate this model. So you can see we've run through 26 million rows already. Generally takes less than a minute to get this done on this 2-node cluster. We've run this on even bigger clusters. So as you just scale out, you throw more machines in your cluster. This just runs faster. all of our, I'm doing a linear regression here, but of course I could have done decision tree, I could have used k-nearest neighbor, I could have used any of our other analytic operators within this context, and they would be able to run distributed also. As it's running, I can actually get some information about what's going on. So I can see this job, jfalgu is my username, and so it kind of tags that onto the name of the job, and airline regression is the workflow that we're running. I can actually see some information about the JVM that's running on that on the nodes within the cluster. I can actually get information about each of the operators that are running. Get some execution details. This was the one that we ran earlier. So I can see like CPU time for each of the individual pieces. I could even break that down per node within the cluster and per operator within that job. And the connection details within show me row counts and how many rows have I read, how many rows maybe if I haven't had to do a sort and such. So that allows me to kind of get more information, get some profiling information about that. Okay, we're going to look at just one more real quick. This is using milestone data. Again, this is benchmark data. It's about, I think about 10 million rows of data. Let me go ahead and start that up real quick. We're reading that data and doing a little date value extraction, actually pulling out a year and a week from the timestamp embedded within the data. So you can see you have 5 fields, an event ID, a timestamp, a site ID, a compromise field, and we're just looking at this, and kind of like David was talking about before, security being a very big area for big data. We're doing a kind of a cybersecurity type of benchmark where we're going through, looking for sites that were actually compromised, doing an aggregation of that, and then being able to report on that. So again, you can see with this environment, it's very easy to use, kind of drag and drop. I'm able to kind of pull these pieces together very quickly. I don't have to know about distributed programming, and I can handle very large amounts of data very quickly. All right, let's see, our airline migration is still running. And I think, let's see, we're actually kind of running low on time for the demo. So I think I'm going to go ahead and hand it back over to David, and we can walk through the rest of the slides.
Cool desktop.
Thank you. It's a great place, isn't it?
Okay, so Jim, we want to make you the presenter again?
Yep, got Joe the presenter, and we'll be able to walk through the rest of the slides.
Okay, there you go.
Okay, thank you, Jim. That's great. So really just one more slide here before we wrap on our end and hand off to Robin. That is a quick look at the, if you like, at the architecture or the underpinnings of the software that you just saw romping through large amounts of data in a very shortest amount of time. And really, if you look at this slide, there's you were looking at the user interface piece there. In the top left corner of this slide. There is underneath this, or alongside this, because of the way we've built this software, there is a scripting framework. The significance of that is both for data scientists and developers that prefer to work outside of UI, but it's also the layer at which you can add additional operators or functions to the ones that you saw on the screen that you saw Jim describe, and then an API that lets you take any of these processes and embed them within either other applications or schedule them to run as needed, and so on. And then you can see here that there are, there's a reference to standard operators, custom operators, and data flows, all of which are reusable in one form or another, they're shareable. And on the left-hand side, you can see there's a reference to different roles. So we have here as we described earlier, something that approximates to an end-to-end, both ETL and data mining and data analytics and reporting product, all in a unified stack, with the possibility of having different roles in the organization collaborate and add value and utilize as appropriate. And then, of course, over on the right-hand side, you have your deployment options, or indeed your development and deployment options, so that anything you build on your laptop will run automatically, scalably, dynamically on clusters as well as on more traditional big servers with, say, 4 CPUs with each with 8 cores, so maybe 32 core boxes, which pretty substantial hardware for running robust data processing, but the scalability that things like Hadoop offer you on top of that as well. So that's a quick overview of the architecture, or some of the simplified architecture of the product. At this point, I'm going to hand back to, I'm not sure if it's Robin or it's Eric who's going to pick up.
I'll just go ahead and chime in here real quick. That's a very impressive demo, by the way. That's one of the more impressive demos that we've seen. And let's see, Robin, I'm handing the keys to you. Actually, I wanted to hand it back to myself for a moment, and I will do that. We got a couple good questions already from our friends in the audience, so thank you very much for all that. And let me just zip through these slides here and get to Robin. There we go. All right, I like that right there. So, Robin, I'm going to make you the presenter, and you want to go ahead and move your own slides. So, hold on. I'm giving you the keys to the WebEx car at the moment. Okay, just click anywhere on that slide and use the down arrow on your keyboard.
Okay, I'm good. Wow, I didn't mean to do that. Oh, it's an Apple keyboard. It's completely confusing. I'll go back to the first slide. Okay. Well, I've not. I've followed DataRush, but I've not seen any of this stuff before. So it may be that I actually asked different questions than the one that I actually put up, which were just based on the slides. But in order to position it anyway, we hear a lot about big data, and nearly all of what I would say the popular articles on it and discussions on it, a lot of it is around big database. Of course, there are now a whole new generation, I think, of big database products. We're not going to do big data in any conventional sense without doing big data flow. I mean, this is the, if you like, it's okay having big heaps of data, but they're not going to stay big heaps of data that sit in a corner. So, I mean, this is part of my message, I suppose, or part of what I think is actually going to happen, and it's going to happen fairly soon if it's not already happening. So basically at the moment, big data is kind of a project on the side. It may even be a kind of guerrilla project on the side where some guys in the IT department have downloaded Hadoop and started to demonstrate that they can, grab all the archived data and throw it into a big heap and process it in parallel with Hadoop and all of the stuff you stick on top of it. But it's not going to stay that way. No matter where people are messing with big data, it's not going to be isolated. It's not going to sit in a corner. It's going to start to be treated in the same way that the data warehouse has traditionally been treated over the last, I don't know, decade or so. So the point is that once you start gathering data and once you start finding value in data, you don't stop. What you actually do is you just add it into the infrastructure you've got. So in my view, the big data heaps are here to stay, and that means they're going to require a data flow architecture. And also, when I was putting this presentation together, I just had the thought that, Hadoop and Hive and HBase and Pig, all of those things, very useful, certainly very useful for prototyping things, but that may turn out to what they turn out to be what they really were, that they were prototypes for actually putting in position something that made much more sense, looked much more like infrastructure for actually handling the big data loads and for integrating the big data loads. And all of that is a huge job of work compared to what we did before. So I would argue that a data flow architecture is now required, or a data flow architecture is soon going to be required. You could say that we had a data flow architecture for data warehousing, but we've outgrown that, and we're moving into a much bigger world of data. And this is what I kind of trying to illustrate here. 15 years ago, there wasn't really much other than corporate databases that were data gathering transactional data from various kinds of applications. And of course, unstructured data came, and certainly with the advent of email and the advent of the the web, we started to have a fairly large amount of unstructured data. That also started to get pulled into the universe of data. And then we got the personal databases, and certainly in the area of BI, pretty much every BI product you come across nowadays has the ability to reach into little heaps of data that are in Microsoft Access or Microsoft Excel or any equivalent kind of place. And then, you know, the corporate data, well, you know, the data universe started to move outside. Of course, first of all, it moved down to the customer, because everybody wants to sell to the customer, and a lot of data is gathered on the customer, but it also moved up the supply chain, and organizations started to see themselves in an ecosystem, and the data started to reflect being in an ecosystem and needing to actually have access to that data all the time. And then we got the advent of web data in all its forms, and also the advent of web-facing systems, so the transaction load rose, and the amount of data rose. And in actual fact, every one of these little boxes I've drawn actually means more data, or means data being integrated with other data, so collectively more data. And all of these boxes actually are growing. And the latest nuance here is the addition of social network data, and it turns out that people say nice things and nasty things about companies, about products on Twitter, and therefore, you know, the company needs to try and, or the companies involved need to try and nip in the bud any kind of negative comments that are made if they can, and therefore they actually are interested in social network data, but they're also interested in social network data arriving very fast, and are also interested in blending that with other data to get some understanding of, you know, how significant it is that somebody in, you know, Tennessee thinks that Coca-Cola is not very good, or doesn't taste as good as it did 25 years ago, or whatever one's opinion is. And then we've got this little outside box called embedded systems data, and this is going to be the mother of all data explosions, in my opinion. I think the slide that David showed is completely correct, possibly even an underestimate. If we look at all of this, and we look at all of the things I've told about, all of those various boxes aren't actually integrated data. Pretty much they are held in different places within an organization, in different little heaps of data. And you not only have the challenge of big data and big data flow, but you also have the problem of data pool proliferation, and the need to be able to mash that data up. People use the word mash up now. I used to just think of joining data, but actually to mash it up and make discoveries within that. In other words, you are looking at a data universe, and you're not only, in terms of the data universe, you're not only thinking of the data flows you recognize, but you're also thinking of combining one thing with another, and that creates mathematically what I regard as a combinatorial explosion. In other words, you get complexity because you're now looking at networks with many nodes, you know? And that means, as far as I'm concerned, that even with the best parallel integration ETL type of technology that you can think of, you're not going to do this point to point. You're not going. I mean, you know, the whole of the ETL thing started with people writing code, and eventually it became obvious that, you know, apart from anything else, nobody wanted to maintain that code, and therefore you need ETL tools. But you know, ETL tools were fundamentally point-to-point things, you know. And now there's going to have to be data flow to actually manage this kind of combinatorial explosion. There's going to have to, in one way or another, it's going to have to be fairly sophisticated. It's going to have to be stuff that you can, in one way or another, manipulate very easily and change very easily, and isn't high maintenance, and so on and so forth. And the other thing to say is, you know, if all of this big data wasn't delivering value, nobody would do it. Because it's hard, right, in the sense that an awful lot of, you know, people never managed petabytes before. And when you start to roll up petabytes of data, there are problems you run into that you didn't particularly anticipate, because you never did that before. You know, most of the guys that are managing petabyte heaps of data right now are managing their first petabyte heap of data. And whether they're doing that in Hadoop and spraying data all over the place with it, or whether they're doing that in some really well-engineered database, it's the first one, you know. Pretty much when I was a guy that built systems, pretty much every time I did something new, I screwed it up and had to do it again in order to actually learn how to do it right. You know, you turn one and burn one. So I would expect that what will actually happen with what's going on right now with big data is it's the first generation, and it's going to be superseded by something that's more organized and easier to manage and probably less expensive in terms of the real cost of ownership. You know, because part of the problem here is the cost of acquisition of Hadoop and a big heap of data isn't that high, but the total cost of ownership could be very high. So let's just talk about the revolution, or what I would call the impending revolution of embedded technology. We had the PC revolution, the internet revolution, the mobile revolution, and they were all surprises. We didn't know, you know, as we lived through them, we didn't see how it would all go down. And there were a lot of things that happened that were new to IT and new ways of doing things that we had never really been able to predict. You know, we could have predicted once, you know, you had the Ethernet standard, we could predict that there was going to be a lot of big networking. For a while, everybody thought, for example, that it would all be like, you know, Prodigy and AOL and all of those things, that would be private kinds of networks. But, you know, the Internet just kind of came from nowhere and just laid all of that waste. You know, and the mobile revolution, we've been knowing that there was going to be a mobile revolution ever since mobile phones started selling really in large numbers at the beginning of the 90s, but the actual mobile revolution that's happening right now was the revolution that was launched by the iPhone and truly smartphones. And it turns out to be really also a lot of things that were not predicted is actually happening. We didn't, you know, we may have thought in one way or another that the mobile phone would be a big deal, but we didn't think that it was going to kill the camera. Well, it pretty much has killed the cheap camera right now, and for all we know, it'll kill the expensive ones in time. And this is the point about the embedded revolution. We don't have much embedded stuff, but if we do have embedded stuff, we have it embedded in various ways that are familiar to us. So we have it, you know, we have obviously RFID and the movement of goods with RFID and all of that. That's reasonably well understood if you take a look at it. And we've also got embedded technology in things like, you know, oil pipelines and so on and so forth, because it just kind of pays for itself. But most of that stuff has been done, again, as first-generation sensors doing things. What we're actually talking about with the embedded revolution is the stuff is going to be everywhere. So just ideas, a cup that knows what's in it, a cup that knows whether there's coffee in it or water in it, a cup that knows whether the coffee's hot enough or not. Objects that can report on themselves, objects that have logic embedded in them that is rational towards their usage. A house that knows who's home, you know, so it knows which TV channel to turn on, you know, and so on and so forth, you know. A car that knows how much you had to drink. If you start to network this stuff together, then by examining your bar tab, which is probably electronic in some way or other, the car can know if you had too much to drink. And then people can start swearing at their cars because they won't let them drive them. There's a whole series of ideas. I mean, it's quite clear that, you know, especially people that are growing older and more in need of healthcare, that they're going to have sensors all over them, and they're going to know what state they're in, and they're also going to be able to report their state centrally. And this is the revolution that actually is going to happen, but, you know, I'm just guessing at it. In the future, I think we will be, in one way or another, I think we'll be looking at incredibly surprising applications of all this. But the point is it's coming. You know, the RFID tags are already incredibly cheap, and the readers are getting incredibly cheap, and the networks are all in place, and the networks are getting more and more powerful in terms of bandwidth, and we now have the databases that can hold the data and so on. You can see where it's leading, and it's going to change the world yet again. Okay, so this is a vague summary. The challenge is speed and complexity. Big data, in my opinion, has only just begun. So think of current big data projects as the early spreadsheets. They're fairly primitive compared to what's going to happen. Data flow architecture is already an issue, and in my opinion, it's going to become a huge issue. The complexity is increasing, and by that I mean the complexity of the data pools and what people are doing with it. And speed is the enabler, or it's the barrier. I mean, you know, if you can't do this stuff fast enough, and it's been the same with pretty much the whole of BI for the whole of its existence. If you can't do it fast enough, it won't be done at all. So that's all that I've got to say. I had a set of questions. I'm kind of inclined to just depart from the script, but maybe I should run through these. David, because you're the one with the marketing mind, what product classification would you say this was?
It's a great question. It's clearly it's arguably a data mining product without any question. It's clearly a big data ETL processing kind of a product, and because it marries those two things, it's a little bit tough to classify it. I'm not sure that there's a data flow category of products out there right now. I'll leave that question to you.
Well, there isn't, basically. What you've got is you've got advanced ETL that's got some kinds of parallel capability, but you haven't got anything that I would say was an overall data flow architecture. So I think you're actually breaking new ground, but you probably don't, from your marketing mind, you probably don't want to be putting a new classification. You probably want to just straddle two well-understood classifications, because you are, you know, with data mining and with ETL, you're in two places here.
Well, we are, but certainly specifically focused on big data. So the data flow imperative, if you like, and I think we've talked about this before, is clearly there. You've outlined it really well. But I think for most potential customers or partners of Pervasive, in the end, it's wonderful horsepower under the hood. But what really matters is how usable is this, or in what form are we going to deliver this kind of power so that it can be used. And we've got other product plans to make this available for other functional purposes of one kind or another.
Right. I mean, because it's not clear, you know, just from a demonstration. It's really not clear. And again, this is not the next question on my question in the slide. It's really more. I looked at that data flow, and I looked at the ease with which you can just kind of paste a data flow onto the screen there, and then join things together, fill in what might be missing, and then away you go. And I just looked at that, and I just thought, well, actually, you could just be doing a whole data flow, the data flow around the whole data warehouse architecture with that. You could have at the, you know, as the starting nodes, you could just have the replications from the transactional data stores, and then you could be doing all the ETL in that. You could be putting stuff into the database. You could be doing data cleansing stuff as you stuck it into the data warehouse. At the other side, you could be pulling stuff out of the data warehouse into data marts. You could be creating operational data warehouses. I mean, it looks to me like you could do that. Is that right?
Yes. Short answer is yes, it's right. You could use it for that, and of course, it doesn't take away from all the infrastructure and the discipline that you'd need to apply to data that you want to retain in your data warehouse. I think one of the more interesting propositions going forward is how big can you make your data warehouse, and what kind of data store is that going to be? Which is a question we'll probably park for now. I think what's even more interesting here is that aside from feeding data in and out of a data warehouse, these very same flows could be operating on the flow of data itself. Your first slide said it so. There's no big data without big data flows. And an awful lot of analysis these days needs to happen on the flows of data themselves, even before they get to a data warehouse.
Yeah, I agree with that. I mean, and it's become apparent, and I don't think it became apparent until we actually got into the situation where latencies suddenly started to become very problematic for certain kinds of analysis that needed to be going on. And then you suddenly realize that actually by sitting down at the beginning, you know, like let's say 15 years ago, and designing a data warehouse, you kind of committed yourself to, you know, sticking a nail in the ground here, and we're going to, you know, we're going to build a house full of data here, and that's kind of determined what you can do later, because you've got this big data warehouse. But in those days, we didn't design data flows. So there's a question that kind of surrounds, I think, a tool like this is, would the points at which you actually put databases be something that you thought of later after you'd started to design the data flows? I mean, I don't suppose either of us can answer that question, but it's certainly, you might want to start with the data flow, especially when you've got time, especially when you're talking about big data. Because, you know, the point really is that I'm well aware of DataRush's capabilities as a parallel engine. You know, the point is that you're really not going to process big data and be able to throw it around to lots and lots of users without having parallelism from the beginning through to the end. I don't think that's going to happen unless you have that, because it's just going to be too hard to manage and maintain. So you might as well have it as default, right?
Yes, you might as well have it as default. And it does mean that going forward, if you're starting to think about a new data warehouse today, or of building on top of what you have and enabling a wider variety of, if you like, rapid uses, your architecture might change somewhat. You've got the scope, with data storage costs being as low as they are now, you've got the scope of actually storing all your raw data anyway, and then doing some further work on that with some pre-aggregations, as you would maybe in a traditional data warehouse. And some of the queries that you're going to run make more sense to run across the raw data, or some of the analytic modeling that you're going to do. And in fact, you know, the idea in the past was that you built a model, you tested it, then you carefully put it into production, and then you monitor it. And I think with the volume of data, with the rate of change there is, and with the ability to do the compute that we looked at today, you can start thinking of rather different scenarios where you build 10 models because you're not sure which one's going to perform best. You keep all of them running asynchronously with the flows that are going into your data warehouse, and you swap them in and out based on which one's performing best this week or in this region or with a particular collection of variables. And you know, that all that compute power that's there, it's there for free if you've got something like DataRush and data flows. So the whole concept of the data warehouse becomes something that's even bigger, that contributes not just to, let's say, rear view mirror analytics, but to operational analytics which are implemented much closer to real time.
Yeah, I think that's right. I think that because if you actually look back and you see what people have built, and you run into things, and you look, what is an operational data store? An operational data store is something we had to put in place. It's a rubber band job. It's something we had to put in place because the latencies through the data warehouse were too slow. You know, so it's like, and these were put in place, and obviously to serve some kind of BI function, some of which may well be data mining, some of which may actually just be standard reporting, but it had to be 15 minutes ago, not a day ago, or something like that. So the idea that what you could actually do is you could look at the requirements at the end of the you know, the requirements that you're intending to implement, also bearing in mind that whole new requirements are going to come along, and that you could design a data flow for each requirement in one way or another, and you might end up with a humongous data warehouse in the middle, but you don't even necessarily have to assume that there's going to be anything like that, But there are going to be some data heaps, and in the future there's going to be some big data heaps. Just a question. I know you're going to say it's very fast. It's like, have you got any idea? If I could do some of what we're talking about here with Hadoop, it's quite clear. I'm going to have to get my hands dirty and do some coding, and I'm going to have to strap together a few components on top of Hadoop. But have you got any idea as to the kind of speed of RushAnalyzer if you imagined it replacing a job that you might use Hadoop for?
So, David, I'll get that one. This is Jim. Robin, I think. Yeah, Robin, I think one thing that's really interesting. In fact, one of the jobs that we ran on Hadoop. I think sometimes when we think about Hadoop, we think about MapReduce, and we kind of limit our thinking to that. But Hadoop is a really large ecosystem of lots of things built around kind of this core, which is Hadoop, and the core of that is really a distributed operating system. Now today, that distributed operating system called Hadoop really only supports one application type, and that's MapReduce. In the future, it's going to support more, right? Next-gen MapReduce is coming out, and actually it's out now in beta format, and we're starting to build on that. Other people are starting to build on that. And so you're going to see a lot more computational models on top of Hadoop than just MapReduce. MapReduce would just become another one of those. And that's kind of part of where we're plugging in. And the idea there is in that you're using all the goodness of Hadoop, the distributed file system, Zookeeper for doing management. You have HBase for doing large data repositories, key data repositories, Flume for doing input of data from different sources. So the idea then is that you're using Hadoop as that kind of central repository for that kind of central distributed operating system that you can take advantage of, and that's kind of where we plug in. And so, looking at the job that we ran on top of Hadoop, would that job run faster than MapReduce? Kind of depends on the job. We've run some jobs where we've seen using Data Rush underneath the covers, which is our parallel technology that's also distributed. That's allowed us to run jobs maybe 2x, maybe 3x faster than MapReduce. Other jobs we run about head-to-head, but I think a couple of things that we bring to the table are scalability, of course, but also usability, right? So the ability to be able to build these Hadoop jobs without having to write a line of code. One of the big problems with Hadoop today is just being able to get people who know it, people who are experts in it, and just getting that human resource in place who can really help you do things. One thing that we're really focused on is making that easier, making it as simple as drag and drop, so you can do these kinds of things integrated inside of Hadoop, running distributed code inside of Hadoop, taking advantage, full advantage of that resource without having to be an expert on distributed programming, MapReduce programming, right? Just kind of taking that abstract, kind of abstracting it up a level and making it much easier. I think that's really important.
Okay, I'm going to have to pass back to Eric and let I'm going to throw you to the attendees.
Great. Yes, thank you very much. We have a lot of really good questions here, and some of them are very specific. So just do the best you can to answer them. Let me just kind of scroll through these. A lot of really, really good questions in the queue today. And folks, you should be able to see them, presenters, in the Q&A tab. So let me just jump on this one. This is a great question. One of the attendees wants to know, can you create a real-time, ongoing ETL job that constantly loads data, such as Twitter feed, for example, and have the analytical tools run independently on the result at any point?
Yeah, absolutely. And in fact, that's one of the points of our integration project that we have is to be able to do this kind of real-time integration where you continuously run these jobs, pulling data from whatever source it may be. Sometimes that's like a file repository where an kind of FTP type site, or it's a message queue, or it's something like Twitter. Dumping the data into your repository and then running your analytics periodically. That's a very common use case.
Okay, good. And here's a specific question about, and is it KNIME? I forgot. How do you pronounce it? K-N-I-M-I-E?
It is KNIME. Yeah, that's correct. Okay,
so one of the attendees wants to know where and how do KNIME and Rush interface? Just kind of curious, do they run as libraries in a single JVM, or are they loosely coupled apps via data pipes? How does that work?
Yeah, they are running inside the same JVM. NIME is a open source product that we integrate with. It's has a plug-in type architecture, so we've actually built out a lot of our functionality using that. But kind of one thing we did a little differently than you see in a lot of NIME plugins is we actually built an infrastructure. And if you've used NIME before, you may have noticed when I was running those workflows, you saw that kind of data flow flow of data, record counts being updated all over the place, everything happening at once. That's a big part of what we added to that infrastructure. So it's not just the operators that we've added, it's also kind of this whole runtime environment that we've added into that also. And that's why we kind of brand that as RushAnalyzer. Built on NIME, so there's a lot of goodness that you get from that, like other plugins for doing the reporting, some of the BERT integration that I showed, that just kind of comes with NIME, and that's a great, almost like a portal, right? It's a way to bring all these different applications together in a way that you can use them together.
Okay, good. And here's another very good question. One of the attendees wants to know, in terms of data flows, could it make sense to run an analyzer like this during a file transfer or synchronization process? Does that save processing power or time, for example, and make some types of analysis possible that would not be possible otherwise?
Yeah, that's definitely possible, and we've done that with a project where we're working with NetFlow data coming off of routers, and we actually plug into Flume. Flume is a open source framework for getting data from different sources, kind of bringing it into HDFS or bringing it into HBase, for example, which is what we were doing. And we're actually able to run in a pipe, kind of in that Flume pipeline, and that allows us to do some pre-processing of the data before it actually even gets into kind of pre-processing of the data on the fly, which allows us to kind of do some very efficient munging of the data before we even hit it, before it even gets into HBase, for example. Yep, okay. So that's definitely possible.
Okay, good. And I think I know the answer to this, but feel free to elaborate. Here's a very simple question. Can the tool handle complex event processing?
Well, it's really not really meant to be, and I'm trying to be careful here because when you talk about complex event processing, there are a lot of tools that are very focused on kind of tick, kind of stock tick data. They're very latency, aware, down to the millisecond or even smaller than that, right? We're not that type of tool. We're really more about not quite that level of latency. So I'm just being careful with calling it a CEP tool. We do a lot of CEP-like things, but just being careful there because that's such a sort of
very specific thing.
Yeah, exactly. Right.
Okay, good. And here's a fairly simple question. One of the attendees asks, is the ETL processing as well as the data fully parallelized? For example, are complex transformations executed using MapReduce? Well, they're actually executed. The ones that I showed where we're using RushAnalyzer, they're executed using our engine called DataRush, which is distributed also, much like MapReduce would be. And so yes, all of our operators that we looked at, we saw that whole list of operators there. All of those are parallelized, and they also will work distributed. Okay, and here's another question: can Hadoop be implemented on a semi-big data, so to speak? Also, what data gets stored in Hadoop, and what should be in the traditional database? And is the integration between the two, how difficult is that? Yeah, that's a good question. I mean, how big is big data, right? People ask that all the time. So kind of where's the cutoff point where you should be using Hadoop? That's really hard to say. It really depends on the data and the type of processing you're doing on it. I mean, I've seen Hadoop clusters and with data in it that's in the tens of gigabytes, and then seen others with hundreds of terabytes. So it really just depends on your needs, and if you really have kind of data scalable type needs, then Hadoop can make sense. The integration that I showed was fairly simple, I think, where we just build out this workflow. We're able to source data from Hadoop, source data from other sources, local disk, MySQL databases. So if you have the right tool, that integration can be fairly easy. And in that case, maybe you want to have your enterprise data, from your databases dumped into Hadoop. That kind of make your job easier of integrating that data together. But maybe it's better for you to pull it directly from the database and kind of use it with Hadoop data from HDFS from Hadoop directly as part of your process. Really up to you, but if you have the right tool, you can do it fairly easily. Okay, good. And one of the attendees said the demo was great, but wondered about case studies. Do you have anyone using this stuff yet? What can you say about real-world examples? Yeah, we definitely have some great case studies on our website. I think. Sorry, I don't know the latest URL, and we kind of rechanged the website lately. I think David can give that information. But
Definitely have some good use cases there. Like one use case we've been working on recently is with CDR data from a telecom provider, capturing all their CDR data, doing a lot of heavy-duty aggregations across multiple dimensions at a very fine, kind of level of granularity, and then providing that data into a data warehouse where they can then do kind of automated reporting, but also doing predictive analytics on it. So that's a pretty common use case that we see of that type of kind of event data, timestamp type data, and doing that level of processing with it.
Okay, and we have another specific question here. Speaking of key data payloads, are the Hadoop tasks organized around the joined primary keys of the data being fed to Hadoop?
Oh, I'm sorry, can you repeat the question there?
Sure. Speaking of key data payloads, are the Hadoop tasks organized around the joined primary keys of the data that's being fed?
In the in the demo that we did, we're doing some joins, and so those were of course key joins. The data in Hadoop itself had some of those keys in it, and so we're able to work with those. I guess I'm not quite understanding the question.
That's okay. It's a very specific question. And let's see, Robin, I have just a generic question for you, and then I think you guys may be off the hook. So hold on. The question for you, Robin, is, let's see, what are standard practices around backup and recovery for Hadoop? Are they just relying on replication factor or doing more to back the data sources to tape, or what have you heard, if anything?
Well, wait a minute. I mean, Hadoop has got HDFS in it, and it has fundamentally got its own backup recovery capability. It's all bundled into one. So unless you actually turn that off, it's there.
Okay, good. Well, folks, a lot of very, very good questions from the audience today. We thank you very much for sending those in. You can see all May we're talking about analytics, so we have several more events lined up. Intelligence in June, then July and August, of course. And wow, this wraps up another hour plus of great content. A very big thank you to our very own Robin Bloor, and also, of course, to Pervasive Software for stepping into the briefing room. And we're all doing this kind of from the road. I know Pervasive has their conference going on right now in Austin, Texas, so thank you, gentlemen, for peeling yourselves away from that. And Robin and I both have to go back down to the enterprise data world, show ourselves. So thanks again, all of you, for these great questions, and thanks for everyone who dialed in. We really appreciate it. And with that, we are going to end the event. Take care, folks, and presenters stick around for a post-conference. Take care, folks. Bye-bye.